Today we want to start solving trigonometric equations, and we're going to start with sinusoidal equations. What we've drawn here is a sinusoidal function, either a sine or a cosine. Could be both, actually, the way we write trig functions, sinusoidal functions. And I've got this red line representing some constants. So the equation that we want to learn to solve is where the trig function hits that constant. That's where we're going to start. What we're looking for, what we remember from algebra, is that intersections on the graph correspond to solutions of an equation. Intersections on a graph correspond to solutions to the equation, where we think the sinusoidal function equals whatever that constant is. What we want to note is that there will be an infinite number of solutions, because although I've drawn 2 cycles of our sinusoidal function, this goes on forever in both directions. We got to find a way to figure out what all the solutions to the equation are. And so here's what we want to observe. In any one cycle, we're going to find 2 solutions. So I've highlighted that first cycle that I've drawn. And we see 2 solutions in that one cycle. The next set of solutions is exactly 1 cycle later. So once we figure out what's going on in one cycle, all we have to do is add multiples of the period to find out what's going on in the next cycle and the next cycle after that. So we're going to focus on finding those 2 solutions in one cycle. So we need to start by finding those first 2 solutions in the first cycle. Then we just add multiples of the period to find the rest of the solution. And this is how we will be able to find all the solutions to our sinusoidal equation. Any questions before we get started? Yes. Why did what? I just had to pick something. I just needed some horizontal line that would go through the function at the same place at every copy of the function. Note that if I move that red line up and down, that it'll still have 4 intersections, because I've got exactly 2 cycles here of this sine function. So if I move it down to the middle, it hits 1, 2, 3, 4. I'll hit 5 because I'm starting the next cycle. But if I go past down there to this negative 1/2, it'll still hit 4 places. It's right at the middle and it's a sine, then I guess we're going to have 3. But in general, we'll have 2 solutions per cycle, and then the next set will be exactly 1 cycle later. They'll always be in the same spots. So we're going to do this in 3 parts. First, we're going to get the reference angle. Second, we're going to put the reference angle into 2 quadrants. Third, we will add integer multiples of the period. So those are the stages for doing this. First, First, we're going to find the reference angle. For this, we'll need the trig function that's in play and the constant. We're going to ignore the sign of the constant because all we care about is the reference angle. So whether it says sine of theta equals 1/2 or sine of theta equals -1/2, we don't care about the plus and minus on the constant. At the start, we only care about the value because we're just trying to get a reference angle. But that's going to be a combination of the trig function and the constant. So I'm going to write that in absolute value signs because we don't need the sign of the constant yet. We're just going for the reference angle. 2. We're going to determine which quadrants we're in using the trig function and the sign, positive or negative, of the quadrant. We're going to place the reference angle in those 2 quadrants. So once we determine the quadrants with the trig function and the sign of the constant, we're going to place the reference angle into those 2 quadrants. Third, we're going to add multiples of the period to get all the constants. The last step is to just add integer multiples of the period to get all the solution. So step 1, we get the reference angle using the trig function and the absolute value of the constant. Step 2, determine which quadrants we care about with the trig function and the sign of the constant. Then we place the reference angle in each of those 2 quadrants. And then finally, we just make sure we get all the solutions by adding integer multiples of the period to get all the solutions. Any questions? Let's do some examples. I dropped the E from degrees, so I'll just use an apostrophe. So step one, we just rely on our memory to find the reference angle. We have sine and 1/2. We know we're talking about a 30-degree angle. So the reference angle is 30 degrees. Sine of 30 is equal to 1/2. So we're using a sine and the positive 1/2, or actually just the 1/2, to get 30 degrees. Next, we're going to think sine is positive in the first and second quadrants. So the sine and the positive 1/2, the positive part of the 1/2, tells us that we should deal with quadrant 1 and quadrant 2. And then I'll just put 30 degrees in quadrant 1 and 30 degrees in quadrant 2. So I'm going to say theta 1 is just 30 degrees. And theta 2 is 30 degrees in quadrant 2. So there's 30. And here's 30 in quadrant 2. So that's going to be 150 degrees. Next, we note that the period of sine of theta is 360 because there's nothing in front of the theta. The way I add integer multiples of 360, I'll just say plus 360 times k, add integer multiples. So I'm going to have solutions of 30 degrees plus 360 k and 150 plus 360 k where k is an integer. Reference angle, quadrants, and periods. So sine of 30 is equal to 1/2. That's where we got the 30 degrees for the reference angle. And we put that in quadrants 1 and 2 because sine is positive in quadrants 1 and 2. Any questions? So same question, if I change my 1/2 to a negative 1/2, I still have the same reference angle. Sine of 30 is equal to 1/2, so my reference angle is 30 degrees. Here we have sine and negative, So sine is negative. So we'll put this in quadrant 3 and quadrant 4. Since sine is negative in quadrant 3 and quadrant 4. So my 2 in the first cycle, I'm going to draw 30 degrees in quadrant 3 and 30 degrees in quadrant 4. This is going to be at 210, and this will be at 330. So our third theta in third quadrant is 210, and the theta in the fourth quadrant is 330. The period in this case is still 360. So to write down all the solutions, I just say 210 plus 360 times k. And 330 plus 360k. Reference angle, trig function and the value. Quadrants, trig function and the sign, positive or negative. Add integer multiples of the period. If you forget to note that k is any integer, that's not a big deal. I will almost always let that slide. And I will start forgetting to write k. Let's try our sine for a cosine. It's going to change our reference angle and it's going to change our quadrants because we're using a different trig function. In this case, we have cosine paired with 1/2. So now we're dealing with 60 degrees. So the cosine of 60 degrees is equal to 1/2. So that's our reference angle, 60 degrees. Then we note that cosine is negative in quadrant 2 and quadrant 3. So I'm going to put a 60-degree reference angle in quadrant 2 and quadrant 3, where cosine is negative. So there's 60 degrees in quadrant 2. That's 180 minus 60, or 120. And 180 plus 60, or 240. the period is still 360. So our answers are going to be 120 plus 360K and 240 plus 360K. Where K is any integer. Trig function and value give you the reference angle. Trig function and sine, positive or negative, give you the quadrants, the two quadrants. Add integer multiples of the period. Here's cosine theta equals -1/2 or -0.5. We were able to just read what the angle was. So let's suppose that I change that now. Instead of -0.5, I do something that we're going to have to use a calculator for. Let's go to -0.6. We don't know offhand what angle has a cosine of 0.6, but we have calculating machines. Now for the reference angle, we don't bother with the -0.6. For the reference angle, we just care about the 0.6. And we're going to do a cosine inverse of 0.6 because we're looking for an angle. And we're also going to make sure that we are in degrees. So the angle we're looking for is 53. It makes sense. We were expecting something around 60 degrees. So our reference angle is cosine inverse of 0.6. Once again, for the reference angle, we don't worry about the negative. That's going to come in when we're deciding on quadrants. So cosine inverse of 0.6 is 53.1. The negative comes in when we decide on quadrants. Cosine is negative in quadrant 2 and quadrant 3. So I need to put this reference angle in quadrant 2 and quadrant 3. I have the same picture, but instead of 180 minus 60 and having a nice easy 120, my angle in quadrant 2 is 180 minus 53.1. Or 126.9. And our theta in quadrant 3 will be, oops, theta, not Q, 180 plus 53.1. 233.1. These are the two that are in that first cycle. Then we just have to add multiples of the period to get all the solutions. Any questions? Note that this works just fine. If you don't remember that 60 is what goes with cosine and 1/2. If you forget that, you can always just do cosine inverse of 0.5 and 0.5, and the calculator will tell you it's 60 degrees. So you can't miss as far as with degrees. With radians, it's a little bit trickier. You might have a fraction times pi. But with degrees, it's nice and straightforward. Forget if it's going to be 60 or 30. You can always use the calculator and the inverse function. When you're going for a reference angle, you don't worry about the plus or minus on the constant. You're just going for a reference angle. Question? How's everybody okay? 3 steps. And the last one is just like all plus 360K. How's everybody okay? Everybody looks so very sad. Because it's too simple. We were expecting a bigger challenge today. So in all the examples that we had previously, the period was 360, and so life was pretty simple. Let's see what happens if I change the period to something else. Let's suppose I'm going to go back to -1/2. So I change that -1/2 to -0.6. Now I'm going back to the -1/2, so we would still pull the nice easy 60. And I'm changing the coefficients. This is not going to show up. This is going to show up in a couple places. First of all, the period is now 180 degrees. But it shows up in another place. When we get the reference angle, it's not going to be the reference angle for theta. It's going to be the reference angle for 2 theta. We're just trying to figure out what the angle is first. So we know that cosine of 60 degrees is equal to 1/2. So our reference angle is not going to be the reference angle for theta. It's the reference angle for 2 theta. And we're not ready to get rid of the 2. I can't use a reference angle of 30 for theta yet. Because we got to put 2 theta into each quadrant. Cosine is negative. In our same quadrant 2 and quadrant 3. So I'm going to put this 60 degrees in quadrant 2 and quadrant 3. Note that I'm not putting theta in. I'm not ready to divide out the 2 yet. I'm going to put 2 theta into those 2 quadrants. So it's still going to be 60 in the second and third quadrants. So the thing that we want to note here is that we put 2 theta into the quadrants. So don't divide yet. Put 2 theta into the quadrants. Then divide. So theta 2 will be 120 divided by 2, or 60. And theta 3 will be 240 divided by 2, or 120. Now we're ready to add multiples of the period. Any questions? So even though theta is 60 degrees and 120 degrees, even though those two angles are in the first and second quadrants, two of those, if we double them, we end up in the second and third quadrants where cosine is negative. And we multiply the theta by 2 before we apply the cosine. So in the order of operations on this side, theta gets multiplied by 2 first, then we do the cosine. Got one more example. It's going to be moving the 2. So notice I put a 2 next to the theta, so that alters the period. Now I'm going to move the 2 outside to the cosine, and I'm going to alter the amplitude. So here I've gone back to just theta. So the first thing that we'll notice is that the period is back up to 360 degrees. And I've changed the order of the operations here. Instead of multiplying by 2 first, then applying cosine, I've done the cosine first, then applied the 2. I need cosine and the value to give me the reference angle. The problem is that the 1/2 is not the value that we're interested in, because everything on the left has been multiplied by 2. So we're going to divide by 2 first. Now I've got cosine of theta equals -1/4. Now I'm ready to find my reference angle, my quadrants, and all the rest. All the rest is like one more step. In this case, I don't remember what angle has a cosine of 1/4. So I'm going to get my reference angle with my calculator. So I'm going to do a cosine inverse, not of -1/4, but of just 1/4. So cosine inverse of 0.25 or cosine inverse of 1/4, 75.5 degrees. Once again, our cosine is still negative and cosine is negative. In quadrant 2 and quadrant 3. So we got 104.5 18 and 7 is 25, so 255.5. The period's back up to 360, so I'll do 104.5 degrees plus 360K and 255.5 degrees plus 360K. K is still uneven. It's always going to look like that original problem that we had. We're going to have two solutions in that first cycle corresponding to wherever sine and cosine is positive or negative. Whatever quadrants cosine or sine is positive or negative. And then the rest of the solutions will always be one cycle later, because the next cycle is just a copy of the first cycle. So you go for your 2 in the first cycle, and then just add the period. If the period is shorter, just make sure you add the smaller period. Also make sure you put 2 theta, in this case, 2 theta into the quadrants, and then divide by 2. All you have to do now is do variations on this theme. Put like 5 cosine of 3 theta is equal to negative 0.8. Then you'll have to do all the things. You have to divide out the amplitude, calculate the period. I think I said 5 theta. Figure out the reference angle 5 theta. Put the 5 theta in the 2 quadrants, then divide by 5. Figure out the period, add integer multiple to the period. How's everybody okay? Right now, I don't know, is there a quiz on this right now? And I'm like, oh no. Meaning like, oh, then we're okay. I'm not okay. I had my second shingles vaccine yesterday because I'm over 50 and you have to have your shingles vaccine if you're over 50. So I got the second shingles vaccine, so I'm a little loop around the edges. I'm really tired. I probably should have taken some time off. Probably felt better. That's it. Those are all the puns. I don't apologize for any puns. It's math. Puns are an upgrade, so go over it. Any questions? Comments? This is moving into chapter 6. I'm kind of like cherry picking now stuff from chapter 4 and then chapter 5 and then chapter 6. Chapter 6 gets in a little more detail than I care about. They have you solving weird equations, like do weird stuff, but this is the core of chapter 6. Reference angle, quadrants, the period. All right, so we'll continue looking at this in more detail on Thursday, but that's going to do it for today. I'll see y'all on Thursday. Have a good day, and thanks for playing.